Okay, now in this mini lecture, I'm actually going to do three things. The first thing that I'll do is I'm going to run a correlation analysis of this entire set of data. Now, this data set is actually file mreg1.xls, which is learning activity 13.2-1. In the text on page 275. I will put that file out onto the blackboard so you can work with that file. But also, if you just want to look at the data in your book by chance, on page 288, this file right here, the actual numbers here, are also on page 288 of your text. So the first thing that I'm going to do is run a correlation analysis on all of the variables. The next thing that I'm going to do is run a simple regression on variables y and x1. This is actually the same simple regression that we covered in one of the earlier mini lectures. And then the third megastat routine that I will run is a multiple regression with sales as my dependent variable, and then we'll have 4 independent variables. Okay, so we're going to do 3 different megastat statistics runs here. So again, my first thing is correlation analysis. So I go up to add-ins, and I click on add-ins. And then I go over to megastat, and I click on megastat. And I drag down to correlation/regression. And then I go over to correlation matrix. And then at correlation matrix, I'll click on that so that it brings up my little activity box for correlation matrix. Here, let me clear this out. And I'm going to tell Megastat to run a correlation on all of my data here. And notice, in addition to highlighting the numbers in this table, I also highlighted the column headers, sales, calls, experience, and so forth. And now I'm ready for my correlation table. And there it is. Now, you have not really looked at a correlation table yet that had more than one variable in it, but you might notice here the correlation between sales and calls is 0.893. That's what we did in one of the earlier mini lectures, and that's what Oris covers in chapter 9 of his text. But in addition now to running the correlation between sales, dollar sales, and the number of sales calls that a salesperson makes, we can also look at the correlation of sales with what will eventually become the other independent variables that we put into our model, into our multiple regression model. Okay? So this is the column that will give us a peek at which independent variables we think might have a statistically significant impact on our dependent variable. We also see out here that 2 of our independent variables have at least a moderate correlation. The correlation between the number of sales calls a person makes and his or her experience is correlated at 0.591. I'm not really going to go into any detail in this mini lecture, but you'll notice in the text that Oris has a brief discussion about a term called multicollinearity. Let me just write that once so you can. Multicollinearity, M-U-L-T-I-C-O-L-L-I-N-E-R-I-T-Y. Okay, multicollinearity. Now, that word might sound a little bit confusing to you at this point. What you'll learn is that multicollinearity just means that our independent variables are highly correlated with one another. And when our independent variables are highly correlated with one another, it creates problems with multiple regression output. Again, I'm not going to bore you with those details right now, but I mention this only so that you understand one of the reasons why we look at this entire correlation matrix before we actually run multiple regression output. Partly, we want to find out whether our dependent variable is correlated with our independent variables of interest. But we're also interested, in the case of this particular correlation right here, we're also interested in whether any of our independent variables are correlated at a very high level with one another, because if they are, we have a problem called multicollinearity. There's things we can do to detect that. There are things that we can do to correct for it. But the reality is this correlation table gives us the first glimpse to see whether we might have a problem with multicollinearity. Just imagine how you can impress your family at the Thanksgiving table for you to start talking about the notion of multicollinearity. Okay, so now let's go back to our data, and just real quickly we're going to run a simple regression like we did in a couple of the earlier mini lectures. So we click on add-ins, we go to Megastat, we drag down to correlation/regression, and then we drag over and down to regression analysis. Okay, and at this point we just click on that. Let me clear out my little information box here, and it asks here, you'll see first it asks for our independent variable, and then it asks for our dependent variable. Our independent variable, X, is the predictor variable, and this is going to be the column for sales calls. So we highlight that column, including the column header for calls, and then we click in the box for our dependent variable, and we're going to use the number of sales calls a person makes to try to predict how many dollars of sales he or she is going to generate. So I've identified my independent and my dependent variable. I click on OK, and then Megastat will give me my output. And you should recognize this output here as being identical to what we've covered up until this point in these mini lectures on regression analysis. This is just a simple regression model that we looked at from chapter 12. The correlation between the two variables is 0.893. Square that, we get an explained variance of 0.798. So the regression model explains about 80% of the variance in our dependent variable. And what we get here is that for every sales call that a salesperson makes, we predict that he or she will generate about $2,000 in incremental sales.